Thank you, thank you. So thanks a lot, everyone, for staying here until the end. As always, I tend to be nervous in the beginning of the talk. So if you see me nervous, shaking, don't worry, it's normal. I'm never going to get used to it, but I really, really like to do talks and to interact with people, so this is why I'm here. My name is Vitor Alencar, I'm a software engineer, and today we have quite of a big schedule. Let me ask how many of you work with React, knows about the React compiler? Can you raise your hand? A lot of people? Right. Cool. So today, I hope to bring a new perspective. It's a mix of how you should see the compiler, how understand the compiler, which is very important, but also how adopt the compiler. So it's a mix of documentation and also my own experience trying to go through this journey. And I hope you can get there because it's a very complex talk, and I'm going to try to make it in 25 minutes. So please help me out. So before we start, I try very, very hard to become better at sharing things in the social media. I'm trying to create my YouTube channel and so on. So for everyone asking, you can find me everywhere, anywhere. It's Vitor M. Alencar. So it would mean a word to me if you can, add me on the social media. If you like the talk, just ping there. I will also love to answer questions about the talk. So if you have any, just find me out after here, and we're going to have a great time. So let's go to the talk, to the beginning, the React compiler and automating performance optimizations. So I feel a little bit old. I don't know if you can spot this on here. Who had worked with this framework before? Can you also? Yes? Just a few people, which, well, things are changing, or I'm getting very old, which, it's OK. So this is Angular. This is how I start with web development, which was nice, but not super nice. It was a bit confusing for me that my logic and my view are connected, but not really. You declare some stuff, you declare some controllers, but the view, it's a bit of detached. You have the imports, and you have to learn a lot of weird tags like ng repeat and why not. I mean, it had its place, but it wasn't what actually made me excited about web development. And then we had React, so I can try to zoom in here a bit. And in the beginning, React was also not super nice. For example, use classes. I personally not super big fan of classes. It's like this syntax sugar for JavaScript. And it threw me off a bit, but it was, for me, a better way to describe what I was trying to do. And then it was much easier to create your functions, have your UI, trying to connect those things together in the same space. People hated it in the beginning, but afterwards, I think everyone kind of agreed that was a better step up for the web development. And they improved a lot as well. They create hooks afterwards, which make the code even better, more simpler, allegedly, and make at least your code seem nicer. You have less code, so you have to worry about less things, so they say. And this is, for me, was like a breakthrough. I was finally able to create very, very, very nice web experiences. It was great. People in the React team told us that re-render is cheap. You can just do it. Don't worry about it. It is fine. And I believed them. It was super cool, super nice, until you actually try to debug your code and you enable DevTools. And if you just create a normal React application nowadays that creates a web e-commerce kind of thing, you're going to see if you enable DevTools, suddenly your whole application becomes like a Christmas tree, just rendering happening over and over and over and over and over and over. Because, of course, rendering is cheap, but there's a limit for everything, right? So it's very common for us to kind of hit this wall because of the way that React was evolving, it's totally fine. But then they also try to fix this, implementing new APIs. So what do we have to try to fix our performance issues in this case scenario? So first, let's take a step back and try to understand very quickly the re-render mechanism in React, because this is something that people get wrong most often. It's quite interesting because people had to tend to look to components in isolation, when in reality, your whole application kind of connects together. So if you have a tree structure, then you have a parent. And what happened is, if the parents re-render, things change on the top, you end up having this waterfall effect that everything re-renders. And it's quite funny to see that every time that I show this slide, people say, yeah, I get it. This is the way that React works. But in real life scenarios, I see a lot of engineers, creating bug tickets because they look at the components in isolation and say, oh, yeah, this component we never re-render. Why is re-rendering here? And they forget to look up in the tree. So just remind yourself. Then React can be, and it's by design, a little bit over-reactive. So they try to fix this, introducing a couple of APIs for us to address performance with more granularity. So the options nowadays is to go to the DevTools, try to debug your application, and start applying memoization by yourself. So here, for example, we take the same application, and I'm going to show an example of how we should go about it, or like a case that we can look at it. So here we have our e-commerce, very simple. Have like state, and I have a function that adds products to the cart, and I have some helpers here that give me like the total amount of items, and why not? And here on the bottom, I have the UI. So here you can see this is an opportunity for us to improve performance. I could use the use callback, which makes this function here be memoized. Here as well, we have another opportunity to avoid the calculation there. We can use the use memo. And last but not least, if the UI doesn't change that much, we also could use the React memo. And then if now you get a bit confusing with the name, you're not alone. I hate to try to explain to people the difference between all of those trees, because I think not even like the React team kind of fully understood what the naming patterns they wanted to use. So, I mean, it is difficult, but this is what we have today. So if we look to the application now, after we apply those performance optimizations, we have a use callback on the top with a dependency array. Here as well, we have a use memo, 2 instances of it, also with the dependency array. In here, we have an application that, by design now, it's fast, right? Things are being memoized. I'm avoiding a lot of re-renders. It is nice and all, but it kind of also creates so many moving parts. Now you have to keep an eye on the use callback and the use memo and the React memo, and all of those things, they can go wrong. You can't forget about, you can spend much more time trying to optimize, make sure that you're not wasting any render, and later on someone just adds a hook here and passes the wrong reference, and your whole work goes to waste, basically. So that's nice and all, but there's so many moving parts, a bit brittle, it can break very easily. It's not that nice of a DX experience. And it just breaks my heart, right? I like to create applications, but sometimes I think we kind of avoid to go to this rabbit hole of separating things because it can be confusing. Should I use a callback here? Should I use a memo? It does make a difference even. So then again, just imagine you, as I was doing, spending hours trying to really optimize, have a production-ready environment, checking all the renders to go to the use callback, use memo, and memoize my component. And then someone else in our team that doesn't care that much, just go there and change the equality reference, and then you have problems. So this is where the compiler enters. And basically, if I have to break down what the compiler is doing, we have a few steps. First, let me go back. Yeah. So first, we have the AST, and then we have the intermediate representation version of the code. We have the optimized code, and then we have the code generation. I'm going to try my best to go through all the steps, but bear with me. I have to simplify them a lot because that's actually 46 steps last time I checked. So it's very complex. I cannot go in deep in all of those, but I'll try my best to at least give you an idea what is going on under the hood. So we start with how the structure looks like. So we have the Babel plugin, and we have the ESLint plugin, and we have the compile core. So this is basically, this is not Vercel logo, by the way. It's just because, triangles look nice. But yeah, those 3 things is how it's divided. So in reality, the first step, what happens with the Babel plugin, it creates the AST, so it's a visual representation of your code, basically. It's going to take all your code and transform into a structure that kind of describes everything that's inside your code. It's very complex, it's very long, and you can see here that we have the function declarations, what the type it is, where the lines of code are pointing to, and things like that. And then we have a second step, which is this intermediate representation we call lowering, which basically it's now a compiler-friendly version of the code, which, as you can see, kind of describe how we are declaring the variables, where's the connection. It kind of creates this link between what comes next to it, what comes after it, and it makes it much easier for the compiler to detect where the changes are happening, in the memory and where it should look for things. Then we have the optimize part of it, which we take this intermediate representation, we go through a lot of steps, and then we check it, basically the code, like, oh, here I see that you're mutating the code, here's a static reference, here is where you can reuse this kind of variable to optimize your code, and here are where the things mutate. So basically it tells where the React compiler should apply the optimizations and where it should apply, how it should apply as well. And last but not least, we have the code generation part. If you go to the React compiler playground, this is what you're going to see if you, copy-paste some piece of React code over there. It's even color-coded, which is pretty nice. And we can have a look here. This is exactly the code that was generated with the examples before. And if you don't understand, don't worry. I took a little bit of time to translate the code gen to something that we can actually go step by step and trying to see what type of optimization we're applying this example that I gave. So first, we have the static values. So basically here, the compiler tries to memorize the static values to avoid re-rendering on this empty array for every render. So here, it checks for the cache. If it exists in the cache, it tries to return from the cache. If not, it adds to the cache, and it returns to you the memorization version of it. Same with functions. So here, we have the compiler trying to also be very clever and prevent, again, the unnecessary re-renders by making our function also memorize. So same as before, we have to look if it exists in the cache. And if it exists in the cache, it will return for the cache all the time. And if not, it adds to it, so we can avoid re-renders here. And same for the JSX output, which now we can check the result of a component to see if they change it or not, and if they exist in the cache. If not, just return it, right? So in summary, trying to visualize what are the steps that we are going through. Basically, right now, we have the separation here of static values, functions, the memorization of the JSX output. And it's basically automatically happening. So you go there, you put your code, you enable the compiler, you're going to see those things happening. And it goes a little bit beyond, right? Like, so here, just by doing those things, we kind of reach the code parity with the example that we had before, where we don't need anymore the user callback, we don't need anymore the React memo or to memorize things manually. But it goes a little beyond of that. Like, the compiler also tries to be very smart. So in this example here, you can see that I'm declaring a variable, but I'm using this variable as a static value. So what the compiler does, and it understands that, right? Like, oh, this variable is not changing. So I don't have to worry about trying to recreate this variable. I could just use the static value directly in the text. So for the things that change, I would still treat it as a variable, so you understand the relationship in between, and it tries to optimize your code like this. So here's for my Brazilian friends. So here's where the gold is, if they always ask me, to come to Portugal and find out. So basically, so far, so good. I think you probably have seen this before, but I also trying to bring a lot of my own experience trying to adopt the compiler, because there is some obvious stuff, there's some stuff that is not so obvious. So first of all, how do we do it, right? I see so many different options that people try to do, basically saying, okay, let's do it all at once. I heard somewhere that you could just enable the compiler, things will be nice, nothing's going to break. Let's just do it. And I have some people being more conservative, saying, OK, no, let's just try one component at a time and see if it works. If it doesn't work, we bail out. We know they're going to use it. So here's a suggestion that I try to applicate in my own work. So first, install it. I think that's pretty basic. Take it for granted. But then we make it work, make it right, make it better. And we keep repeating this loop, this feedback loop, over and over and over until we reach the end of it. So first of all, install the compiler. I have a slide for that, but you can just go to the docs. But it's always nice to show you. And here's what I do first. I can run this health check to see how many of my components have the compiler violations, right? Because a nice side effect of having the compiler, we can run and check how many of the components are not following the rules. So here, for example, is the output of it. You can see that it goes through all my components, trying to figure it out. OK, can I optimize it? If I can't optimize it, what should I do? Should I just bail out, inform the user? And you can play this in your CI. You can try to do some clever things here to get some reports. So I talk a little bit about the rules, but it's always nice to remember, right, more often than not, because React was created to be very flexible, not opinionated. I think it took a lot of time for them to actually create some rules for people to follow. And they assume that you're following those rules, which is the rules of hooks. And here's a funny bit. So I had actually, in my current work, a long discussion with one of the engineers there, because when we tried to actually opt in for the compiler, he was very confused about the rule of hooks. So he wanted to pass hooks as props for functions. And because it actually doesn't break, it's a bit hard to tell him that, hey, you know what? People that create React actually said that this is against the React rules. We cannot optimize for it. But it's very hard to judge since it was working. The application was working. So we have to look back and actually try to internalize the rules. So if you take anything from here, just try to follow all of those rules because they are very important. So making components being pure and your hooks as well, trying to make sure that you're not violating them. And then if you can run the compiler as well to see which component will violate it, it will be very interesting. So afterwards, another thing that I would recommend very strongly is the compiler is not something that you just enable and forget, although it's called React Forget. I really ask you to go there and then do some debug sessions, because the compiler can only do so much. It just tries to optimize your React components. If your application have functions outside of React, they are not memoized, it's not going to do any work for you, right? If anything, it's just going to be there, and you're going to assume that things are working where they're actually not, and you will be surprised. So what I always do, I try to go for the components that I have, see which ones are kind of like broken, or which ones are not being memoized at all. And for the things that you can fix right away. For the things that you can fix, you can, see the errors, see where is the compiler is trying to exit because it can't solve it. And then you can add the use no memo to tell the compiler directly, hey, I don't want to work in this component right now. Please don't try to compile it. And I give you a better one. Be the guy that actually goes there and comments the Jira ticket, because just trying to forget the compilation is not going to help you in the long run. Believe me, I was one of those people. So if you can, every time that you use no memo, please attach any kind of ticket system to it. You're going to be much happier, and you're going to thank me later. So use the DevTools. There's this nice extension that tells you with this little sparkling icon when the components are memoized, when they are not. And you're going to be surprised, actually, that sometimes, even though we enable the compiler, there's no warnings or we're not, we're still going to have parts of the application that are not being performed at all. And this can help you to identify where this is at. So another thing, benchmarks are very important. We have to use them with a grain of salt, because it can be a mixed bag. Some people have a very simple application. They use the React compiler, and they go on the internet and say, hey, I didn't see any difference. This is probably because maybe you have already memoized what you could memorize in the view area of your code, and there's not much to the compiler, for the compiler to do anyway. But if you enable benchmarks, especially in the CI, this is an example of the Vanity IO, I think so. And I found very interesting. They have this in the showcase for the discussions in the React compiler on the GitHub. And they actually trace the latency and the improvement that they did. This helps to keep the compiler honest in continuously with the development of the feature. So always try to be based on data. That's very nice, very important. And again, it's not magic. And although the React team had been working with this for a long, long time, it's becoming more and more mature. there's still bugs. Like this is my first week with, this is a friend of mine, Lucas. And it was funny because as soon as I joined my company, I was talking with him about enabling the compiler. And he's a very good developer, by the way. 5 minutes in, he identified 3 different bugs that they have in the compiler. And he just opened like some issues on GitHub. And I was very surprised to see that people there are like also very, very talented and very, very fast. Within like a week or a little bit more than a week, they actually resolved those issues. So be the pull request that you want to see in the world. Like if you find a problem, go there, report it, try to fix it, and we are going to have a more stable setup. And yeah, last but not least, because I see a lot of people get confused as well, the compiler, it's not part of React 19, right? You can use it right now if you want to. Actually, with React 18, there's a polyfill for it. But of course, the React 19 version would be more stable, so if you can use the latest version, use the latest version. But the way that I go about it, just to finalize everything here, is like in those considerations. For every new project that I'm starting, I'm trying to opt in for those things. So I go back to my projects that are greenfield projects, and I try to play with those tools to really understand how they work, what they are doing, because more often than not, you're going to see that it's very important for you to have this deep knowledge about what the compiler is doing under the hood. You're going to be able to learn about ASTs and low-level instructions. That's very useful, because if you have a problem, you're going to know how to debug and how to solve it. And use with caution, because new libraries, they can sometimes not work. So last time that I checked, MobX was not compatible with the compiler. I see that they actually started something there, so it's worth to check it out. But as it is right now, they are not compatible. So if your application uses one of those libraries, keep that in mind and try to isolate this part of the code so you can still benefit from the compilation of some of your components, where every time that you have a library that doesn't play well with it, you can at least isolate to fix this later, or to try to, if it's open source, to help other people to adopt the compiler there as well. And I think this has opened so many new opportunities. It's kind of this very, very nice window that, if you're able to pre-process your code with like a compiler, there's so many things that we can think about it. Just maybe we can, I don't know if you, like me, hate those dependency arrays for hooks, and why not? Because I think that they're necessary right now, but they're a bit confusing, right? Like in so many big code bases, I see people just commenting like, yes, Lane, please ignore this line. I know what I'm doing. And 9 out of 10 times you don't. Like you're just creating re-renders that are not be visible for the user. So maybe we can get rid of those. Who knows, It all depends if you adopt it and if we all mature this compiler altogether. So I had a lot more stuff that I would love to go in deep dive and actually show all the bits and bytes here, but I cannot because I only have 1 minute left. So again, if you like this talk, if you want to talk with me, please add me in my social medias. I try to help a lot of people as much as I can to create content for free because I like to help. This is how I started to be a developer in the first place, was because I was joining a conference like this. So please do that. I hope that you like it, and thank you. Thank you very much.